In this video, we will look at how to generate a command file for a shell or plate analysis using Efficient software. This plate has a dimension of 100 mm wide by 5 mm thick. It is fixed at one end and a load of 2000 Newton is applied on the other end. The mesh for this FE analysis is in MED format. In this mesh, fixed edge is given edge group or a mesh group of fix, and the edge on which load is applied has been given a mesh group of load. Start Efficient if not already started. On the first tab, keep everything as default provided by Efficient. Start should be here, MED should be here, and the type of calculation should be linear static. Click on Analysis tab and select Mechanical Shell from the drop-down list. Next, click on the tab Material. Here, we'll enter parameters for common steel as we did for beam analysis. We'll enter the material name of carbon steel as CS and we'll say is assigned to all and click on Add. Next, let's go to Elements tab and select Shell for the type of element. As soon as you do that, you can see that the section type has been made redundant or has been made uneditable as it is not required for shell type analysis. Type in plate for is assigned to. Now this name has to be exactly the same as the mesh group in the mesh. Enter 5 for thickness. Click Add and the section property will be added to the command file. Next, we go to Boundary Condition tab. Select DOF DDL on mesh group. Enter fixed for boundary condition name and enter fix for is assigned to. This fix has to be the same as that given in the mesh. Enter 0 for all dx, dy, dz, drx, dry, and drz as we want this mesh group to be fixed in all directions. Click on Add and the boundary condition will be added to the command file. Next, we'll go to Loads tab. Enter force Z for load name. For the load type, select force on edge as we are going to apply that force of 2000 Newton on the edge. For is assigned to, enter load, and this should be exactly the same as that given in the mesh file. For FZ, we will enter 20. Here we have to remember that the force or load of 2000 newtons is distributed over the entire edge length of 100 millimeters. So 2000 divided by 100 gives you 20. Click on Add and the force will be added to the command file. Next and last, we'll go to the Output tab. As we can see here, there are only two parameters. We'll add all to be added to the command file. Final thing to do is to save this command file. Let's go back to the place where we need to save this file. I'll give this name shell.com. Don't forget to enter COMM. Click on Save and click on OK. Your shell command file is ready. Let's have a look at how does that command file look like. I'll open shell. The element type is a plate with a thickness of 5. So that's what it is. That's what's different from the beam analysis or the beam command file that we did earlier. I would encourage you to use this command file in the finite element analysis of your own and see for yourself.